So let's just pick up where we left off. We were talking about logarithms, reviewing that definition of a log. The other important thing to remember about logarithms is we've got three properties that you can use when you're working with logs. If you have log of a product, you can write that as a sum of logs. Log of a quotient becomes a difference of logs, and log of an exponential becomes a product. And so I want to review how those properties work by just doing some examples. Example A says use the properties of logarithms to express as a single log. So the very first thing I'm going to do is if there's any numbers in front of the logs, I am going to use this third property and I'm going to write those as exponents. So this is natural log of y minus natural log of x to the third. Now I have a difference of logs. I can use the second property and I can rewrite this as log of a quotient. And so that's my final answer, natural log of y over x to the third. I'm going to do the exact same thing in part B. I'm going to start by turning those coefficients, those numbers, into exponents. That would give us log of x plus 1, and then we have log of x to the fourth minus log of y squared. Now the first two logarithms, we have a sum of logs. That's going to become log of a product. Now we have a difference of logs. That is going to become log of a quotient. And so my final answer is log of x to the fourth, x plus 1 over y squared. One thing to notice when you're condensing these logarithms into a single log, once you do a bunch of these, you might notice some patterns. And the pattern is, anytime you have a positive logarithm, like the first two, that ends up on the numerator. And anytime you have a negative log, that's going to end up in the denominator. And sometimes that helps me kind of save a little bit of time and move a little bit faster with these. So let's do one more example. I'm going to turn those coefficients into exponents. So we've got natural log of x to the fifth minus natural log of w to the 1/2 plus natural log of y squared minus natural log of z squared. Now, we can work from left to right, noticing that differences of logs become quotients, sums of logs become products. But I like to save a little bit of time and kind of condense this into one step. And it's always true that anytime you have a positive logarithm, that's going to end up in the numerator when you condense this, and it's going to be a product. So we'll have an x to the fifth times y squared in the numerator. And anytime you have a negative log, those are technically negative exponents, and so those are going to end up in the denominator, again as products. So we'll have a w to the 1/2 and a z to the 1/3 in the denominator. Now finally, anytime you have fractional exponents, those can be written as radicals, and I would like you to do that. I'm going to change that w to the 1/2 into a square root of w. And so there's my final answer as a single logarithm. Okay, the last concept I want to review is how do we solve equations? Equations are going to be popping up all over the place in this course. And so we need to know how to solve exponential, logarithmic, as well as quadratic and other types of equations. And so let's start with this exponential equation, 3 to the x minus 1 equals 7. There are lots of methods you can use to solve exponential equations. The method I like is where you just take a log of both sides. I like to take natural log of both sides because I have a button on my calculator that's labeled natural log. But you could take log base 10 of both sides if you prefer. Most calculators have buttons for log base 10 as well. And then I can use those properties of logarithms, and I can take that exponent, the x minus 1, and bring that in front of the ln3. And now I'm going to distribute my ln3. ln3 is just a number. We could even figure out what it is with a calculator. So ln3 times x is x ln3 minus ln3 times 1 equals ln7. All right, now we're solving for x. I want to get the x by itself. So I want all terms with x on one side, all terms without x on the other side. And so I am going to just add that ln3 to the other side. So I just added the ln 3, and now I have just the x by itself. Finally, to completely isolate the x, I have to divide by ln 3, and there's my solution. X is ln 7 plus ln 3 all over ln 3. I'm going to leave my answer like this, but you could put this into a calculator and get a decimal approximation. And in some cases, we are going to be putting things into our calculator and expressing our answers as decimals. All right, let's do an equation with a logarithm next. To solve equations with logarithms, I am going to take advantage of that definition that I mentioned in part 1, where every single logarithm can be written as an exponential, and vice versa. So I'm going to just take this logarithm and rewrite it as an exponential. The base is 2, the exponent is 3, and this has to equal x minus 1. And now this is actually something I can solve. 2 to the third is 8, I add 1, and I get x equal 9. Now I'd like to do something similar in example 3. I have a more complicated equation with logarithms. I would like to be able to write this in exponential form. But before we can do that, we need to use those properties and condense this so that we have a single log on one side of the equation. And so right now we have a difference of 2 logs, and we have a property that says anytime you have a difference of logs, you can rewrite that as log of a quotient. So using my properties, that left-hand side becomes log base 3 of x squared plus 17 over x plus 5. Now I'm going to do the exact same thing I did in the previous problem. I'm going to put this in exponential form. The base is 3, the exponent is 1, and this equals x squared plus 17 over x plus 5. All right, now I am stuck with an equation with a fraction in it. And anytime I have fractions in an equation, I clear them. I multiply both sides by the LCD, or the denominator, to get rid of the fractions. So if I multiply both sides by, let's see, x plus 5, that gives me 3x plus 15 on the left, and then on the right, the x plus 5's cancel out, and I just have x squared plus 17. All right, now I have a quadratic equation, something with an x squared in it. And so I'm going to set one side equal to 0. And quadratic equations are easiest if your x squared is positive. And so I'm going to subtract everything on the left over to the right. And so that gives me 0 equals x squared minus 3x plus 2. And I think I can factor this. If I couldn't factor, you've always got the quadratic formula. But 2 times 1 is 2, and if they're both negative, that adds up to negative 3. So I've got 2 solutions. X could equal 2, or x could equal 1. Now finally, you have to be really careful with equations with logarithms. You do actually have to check your solutions. And by check your solutions, what I mean is you can't have a negative or a 0 inside a logarithm. In this case, both of these solutions are fine, because if I were to plug them into the original equation, 2 squared plus 17 is positive, 2 plus 5 is positive, 1 squared plus 17 is positive, 1 plus 5 is positive. However, if I had gotten a solution like, I don't know, negative 7, then I'd have to cross it out. We can't have a negative inside the logs. All right, let's solve one more equation. This is another quadratic equation. So I would start by trying to factor. Let's see, 5 times negative 3 is negative 15. So I wonder if there are 2 numbers with a product of negative 15 and a sum of 2. And positive 5 and negative 3 would work. So then I copy down the first term, and I use those 2 numbers to rewrite the middle term as a 5x minus 3x, and then I copy down the last term. Now that I have 4 terms, I can factor by grouping. In the first 2 terms, I'm going to pull out a 5x, and I'm left with an x plus 1. In the second two, I'll pull out a -3, and I'm left with an x plus 1. It's good that I have an x plus 1 in both, because now I can bring that out front, and I'm left with a 5x minus 3. Now that this thing has been factored, I am going to set each factor equal to 0. And my two solutions are x equal -1 and x equal 3/5. Now, if you can't factor, or it's taking you too long to factor, you do also have the option of using the quadratic formula, which I'm going to jot down over to the right. So if I wanted to use the quadratic formula in this problem, I would just plug in 5 for A, 2 for B, and -3 for C. I could then plug those numbers into my quadratic formula, and I could do the math. Let's see, -2 plus or minus 4 minus a minus is going to become a plus, and that's a 60 over 10. So x equals -2 plus or minus root 64, which turns into an 8 over 10. And then if we actually do this math, we get -10 over 10, which gives us the -1, or positive 6 over 10, which would give us the 3/5. Exact same solution. So either method is fine. I recommend that you at least try some factoring. There's some cases where factoring is going to be a skill that's really going to help us out. But you are more than welcome to use the quadratic formula to solve your quadratics as well. All right, so that's it for this first lesson. I know there was a lot of material that we went through pretty quickly. That's how it goes with review material. But I am more than happy to meet with you during office hours. You can always use the tutors on campus as well. So I hope this helps, and let me know if you have any questions.